Imagine holding something smaller than your thumb. No flames, no wires, no sound. Just a small black pellet, cool to the touch. Now imagine that this one tiny object holds more energy than burning an entire ton of coal. It could power your home for years. Or in the wrong hands, it could erase a city from the map in under a second. This is not science fiction. This is uranium. And today we are going to find out exactly why nothing on this planet comes close to its raw and terrifying power. The story of uranium begins in 1789. A German chemist named Martin Heinrich Klaproth was experimenting with a dark and heavy mineral called pitchblende. He managed to isolate something new, a strange, dense element that nobody had ever seen before. Since the planet Uranus had just been discovered 8 years earlier, and he followed the trend and named his discovery uranium. For the next 100 years, nobody really cared. Uranium was used for one thing and one thing only, making glass and ceramics glow with a yellow-green color. That was it. People were literally eating off uranium-glazed plates without any idea of what they were dealing with. Then, in 1896, everything changed. French physicist Henri Becquerel left some uranium salts sitting in a drawer next to a wrapped photographic plate. When he came back, the plate was fogged, burned from the inside. Nothing had touched it. No light, no heat, nothing. Yet the uranium had left its mark right through the paper. Invisible energy was leaking out of the atom itself. Radioactivity had just been discovered, completely by accident. To understand why uranium is so extraordinary, but you need to understand its secret. Not all uranium atoms are the same. About 99.3% of all uranium on Earth is a version called U-238, which is stable and mostly harmless. But hiding inside is a rare version called U-235, making up just 0.7% of all natural uranium. And U-235 behaves in a completely different way. If you fire a single neutron at a U-235 atom, the nucleus does not just absorb it. It shatters. That shattering releases heat and 2 or 3 more neutrons. Those neutrons hit other atoms. Those atoms shatter and release more neutrons. Within 1 millisecond, trillions of atoms have split in a chain reaction. This is nuclear fission, and the energy it unleashes is almost impossible to imagine. To put it simply, one uranium pellet the size of your fingertip holds as much energy as 1 full ton of coal. From something you can barely see. Uranium does not come out of the ground ready to use. The process starts in massive mines in places like Kazakhstan, Canada, and Australia. The ore is crushed and chemically treated to produce a concentrated powder known as yellowcake. But yellowcake is mostly U-238, the stable kind. To make it useful, you need to increase the amount of U-235. This process is called enrichment. Using centrifuges spinning faster than the speed of sound, scientists separate the isotopes atom by atom. For a nuclear power plant, you only need to enrich uranium to about 3 to 5% U-235. But for a nuclear weapon, you need over 90%. That gap between 5% and 90% is where international politics, weapons inspections, and global tensions all live. Because the same technology that can power a city can also destroy one. Inside a nuclear power plant, uranium pellets are stacked into long fuel rods. Those rods go into a reactor core, where the fission reaction generates enormous heat. That heat boils water into steam. The steam spins a turbine, and the turbine produces electricity. No burning, no carbon, no smoke. Just pure, controlled atomic energy feeding into the power grid. Nuclear energy currently generates about 10% of the world's electricity. In France, it provides more than 70%. It is the most energy-dense fuel source humanity has ever used. But the spent fuel rods left behind stay radioactive for tens of thousands of years. And we have to bury them deep underground and protect them for longer than any civilization in history has ever survived. We cannot talk about uranium without talking about August 6th, 1945. The bomb dropped on Hiroshima, known as Little Boy, was powered by highly enriched uranium. In a fraction of a second, an entire city was gone. More than 70,000 people died instantly. The world had seen the absolute limit of what uranium could do, and nothing was ever the same again. Even today, the destructive uses continue. Depleted uranium, the leftover material after enrichment, is so incredibly dense that it is used in armor-piercing ammunition. Denser than lead, it can cut through a tank's steel hull like it is made of paper. The same element, two completely different worlds. In Greek mythology, Prometheus stole fire from the gods and gave it to humanity. Uranium is our version of that fire. It can heat our homes and power our cities without burning a single gram of carbon. It may be our most powerful tool against climate change. But if we lose control of it, there is no undo button. The consequences are permanent. Uranium is more than just element number 92. It is a test of whether humanity is responsible enough to hold the power of the stars in our hands. So far, that question is still being answered. If you found this interesting, hit subscribe, because we have only just scratched the surface.